What is black body radiation? When we extend thermodynamic analysis, we learn that there are three modes of heat transfer. Conduction, which occurs through a solid or stationary fluid. Convection, from a surface to a moving fluid. And radiation, energy emitted by every matter that is at non-zero temperature. Transported by electromagnetic wave or alternatively photons, radiation does not require the presence of material medium. In fact, it occurs most efficiently in vacuum. Without radiation, life on Earth will not be possible. We already know that radiation depends on temperature, but how measure that if every material has different emission, absorption, reflection, and transmission? Well, this problem was solved introducing the concept of theoretical object called black body. A black body absorbs and emits all incident radiation, regardless of wavelength and direction. It is a diffuse emitter and for a prescribed temperature and wavelength. No surface can emit more energy than a black body. As a perfect absorber and emitter, the black body serves as a standard against which the radiative properties of actual surfaces may be compared. Although no surface has precisely the properties of black body, the closest approximation is achieved by a cavity whose inner surface is at a uniform temperature. Define black body. We can now study radiation properties of materials as a massive power rate at which radiation is emitted from a surface per unit area, and is prescribed by this equation, where Ts is the absolute temperature of the surface, and sigma is the Stefan-Boltzmann constant. Epsilon represents emissivity. A number with values is in the range of 0 to 1. This property provides a measure of how efficiently a surface emits energy relative to the black body, whose emissivity equals 1. Emissive power can be also analyzed by its intensity emitted at the wavelength, as shown in the graph of spectral distribution of Planck's law. Here we have wavelength of ultraviolet wave, visible band emission, and infrared wavelength. The line represents constant temperatures. According to the Wien's displacement law, the maximum spectral emissive power is displaced to shorter wavelength with increasing temperature. Since the Sun emits approximately as a black body at 5800 K, its greatest emission is in the middle of the visible spectrum, almost 0.5 micrometers. Then it makes the Sun appear yellow to our eyes. But materials on Earth have lower temperature, so we usually cannot see radiation emitted from the Sun, with few exceptions such as light bulb and lava. Then scientists have created the infrared camera, device that forms an image using signs of infrared radiation and converting them to an image using visible light.